Then we will label this now. This is our point X. This is our point Y. And this is our point Z. Okay. Now, let's assume we just do 2D mole circle. Let's assume. Okay, assume. So I'm going to, okay. So if we were to only construct 2D mole circle, when we will construct the in-plane, which is the X and Y plane, yes or no? We ignore the Z. Let's say now we ignore the Z, we don't consider 3D mole circle analysis. Okay, let's consider, okay, initially, because I want to show to you why is it important to do 3D. Okay, so we initially perform 2D mole circle analysis. So in 2D mole circle analysis, okay, this is X, this is Y. I totally ignore the Z now. Yes or no? And the shear XY and the shear YX, okay, for 2D and 3D, the values are all the same. Okay. So now I will start drawing 2D mole circle. Okay, we will start drawing 2D mole circle. Okay. So I'm going to focus on the tension. Okay. So this is our normal stress, shearing stress, element rotate clockwise, element rotate anti-clockwise. Then we're going to have a condition where stress X is greater than stress Y. Okay. So we have, excuse me. So this is our stress X. Okay. And then this is our stress Y. One. Okay. This is our stress Y. And then we have our shear. Right. And then we have our data shear. So point X, right? Element rotate anti-clockwise. Point Y. And then we know that over here, this is your stress average. Okay. And then you draw your mole circle. We go 3, 5, 1. Hey, sorry, wrong color. Okay, so this is just performing 2D mole circle. Right? So you ignore 3D analysis. So when you perform 2D mole circle, okay, this is the value of your tau max. So for this case, This is equal to your tau max for 2D mole circle, and this is your tau max in the XY plane. Okay, 2D mole circle. You totally ignore 3D. Okay, but when you have 3D mole circle, what you realize that you have another point over here. This is your Z, right? So now you construct 3D mole circle. So the first circle the one circle that you drew, which you are very good in constructing 3D mole circle. So this is one circle, right? So this one belongs to your YZ plane, right? And then the next one, 3, 6, 9. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 6.5. So the last circle now, right? 2, 4, 6, 6.5. You will realize that the last circle is a much bigger circle, right? So what you see now is there's another circle over here, and this circle, right, is actually your tau max. Okay, and this is for 3D, and the tau max is for your XZ plane, right? So if you only consider and what we can see from here, right? What we can see from here is tau max in 3D, right, is greater than tau max in 2D. So you have to analyze what? Based on what? 3D mole circle. Because no doubt Z is equal to 0. Yeah, it's innocent. 0. Yes or no? But the 0 means something. It's like the anchor point. You shift the anchor point. If it's 2D mole circle, this is the anchor point over here. If it's 3D mole circle, this is the anchor point. And you can see the critical part of doing what? 3D mole circle analysis. You cannot just rely on what? You just can't rely on 2D. Okay, so we have to be really what? Careful down here. Okay, we have to be careful. So we cannot that's why this course I insist on teaching what? 3D mole circle. You cannot just rely on 2D. Okay, so I'm going to write some expression. Okay, so the critical thing now, okay, we know that over here this is our stress max, right? We know over here this is our stress mean, and our stress mean happen to be equal to 0. Okay, so now let's see how we can link this to Tresca criteria. So we know that Tresca criteria we know that the maximum stress is equal to stress yield. Whenever you see yield, it's experimental work divided by 2. Okay, let me do something further. Okay, so stress x subscript E, okay, is equal to stress yield divided by 2. Okay, the E down here is to remind you it's from experimental work or data. right? Yield is always from experimental data. From what I've taught you, you cannot calculate yield strength. Okay, you have to rely on experimental data. Then from here, now we are going to determine, right? We are going to determine stress max in 3D. Okay, so we're going to determine this, right? So that's the case. We know that our stress average, okay, in the XY plane, okay, XY plane means we are looking at over here. This is your XY plane, right? So this is equal to stress X plus by stress Y divided by 2, right? And then the next thing we're going to do is we're going to calculate the radius or tau max at the XY plane, okay? And this is equal to stress X plus by stress Y divided by 2 squared plus by shear XY squared. Okay. And then from here, right, I'm going to go to the next page, right? We know that stress max, right, is equal to stress average for the XY plane plus by tau max for the XY plane, right? So what we are going to determine now is this point over here, the stress max. So from here, we write this as stress X plus by stress Y divided by 2. And then plus, then we include the stress X minus one. This one is not plus. I do apologize. Okay. Oh wait. Yeah, it is plus. Wait. So hold on. I'm having a bit of a brain fart down here. Okay. So we know from over here. Okay. So this one is wrong. Okay. So it's stress X. Right? Because the distance from here to here is stress X minus stress Y, right? And the distance from here to here is stress X minus stress Y divided by 2, okay? It's not plus because the distance from here to here is stress X plus by stress Y divided by 2, okay? So that's why it's minus. So this is stress X minus by stress Y divided by 2, okay? And then the whole thing squared. And then we have plus by shear XY squared. Okay. Then from here, this is your stress max value. So now we are going to calculate our tau max. Okay. So our tau max is equal to stress max. And then the whole thing divided by 2. So this is basically half bracket stress X plus by stress Y divided by 2. And then plus by the whole thing square root stress X minus stress Y divided by 2 squared plus by shear XY squared. Okay. So from here, this tau max over here, okay, the tau max over here must be less than or equal to the tau max experiment. Okay, so the tau max experiment from what we had earlier, not here, sorry. Tau max experiment, oh, it's here. Tau max experiment, where's my tau max experiment? One, yeah, the tau max experiment over here. Okay, so this condition, tau max that we calculate must be less than or equal to tau max experiment. Okay, so this is one condition that you can see. Then there is another condition. Okay, so condition, the next condition. Now, before I go on for next condition, right? For this case, equation 1, this equation is only valid, right, when one of the principal stress is equal to, or the stress mean is equal to 0.